Hello viewers, welcome back to this discussion on special relativity. In an earlier video, I proposed a paradox which leads to different frames of reference expecting different realities in an experiment. But that was still only a paradox. But in this video, I am showing what I believe is a flaw directly in the theory itself, right there in Einstein's 1905 paper through simple logic. Einstein's conclusion that simultaneity is relative, frame dependent, not absolute as commonly believed, is the foundation of special relativity. From this only he develops a definition of common time of an event in a frame of reference and Lorentz transformation equations, from which we get strange results like time dilation and length contraction. But if this conclusion itself is found incorrect, everything else automatically gets dropped. Now, let us look at Einstein's 1905 paper to see how relativity of simultaneity is established. This reasoning has three important parts. First, the need to synchronize all the clocks of a frame of reference. Second, how to do this synchronization using a light pulse. Third, the clocks that were synchronized when they were stationary don't remain synchronized once they start to move. The time of any event is given by a clock present near the place of the event. But to compare the times of events that happen at different places in a frame of reference, like whether they are simultaneous or not, we must synchronize all the clocks of the frame. After this, Einstein describes a condition of synchronization for two clocks at points A and B in a frame of reference called the stationary frame in the paper, although it need not be truly stationary in space. A pulse of light is sent from the point A, it reaches after some time to the point B, gets reflected there by a mirror and starts back towards A and reaches the point A after some time. The times shown by the clocks A and B are noted at these three moments. The clocks A and B are synchronized if the time taken by the light pulse in going from A to B comes out to be equal to the time taken in going from B to A when calculated using these three times shown by these clocks. In the previous consideration, it is important to note that when synchronizing the clocks of this stationary frame using this test of light pulse reflection and the time it takes to go from A to B and back, Einstein says we must define that these two times are equal. This is because since absolute uniform motion is never detectable because of the principle of relativity, there is no way to find out if the frame of reference we are calling as stationary is indeed stationary in space or moving with constant velocity. If it is not really stationary, the two times for the light rain going from A to B and back will not be equal, but there is no way to determine that because if there were any such way, principle of relativity would break. So, we are free to call any inertial frame of reference as stationary and define that the two times are equal. Now we come to the most important step in the paper where the argument to establish the relativity of simultaneity is given. Suppose we have a frame of reference with the two clocks synchronized using this light pulse reflection method. Now we take a rod of a finite length and place two clocks at its ends synchronized with the previous stationary clocks present nearby so that all the four clocks are synchronized, and then impart a translational motion with constant speed to the rod and the clocks. Now the observers present near the moving clocks will find that these clocks now don't pass the test of synchronization, the light pulse reflection test just discussed. Because the left and right light pulses that go back and forth between the moving clocks will cover different distances than the left and right light pulses respectively that move between the stationary clocks. So they conclude that these clocks at the ends of the moving rod are not synchronized. Hence, the simultaneity is relative, not absolute. But this reasoning has a fundamental flaw which will be clear with the following consideration. The situation here is similar to the following. Suppose two trains of equal length are standing at rest side by side on a station with only four passengers in total, two in each, sitting at the front and rear ends of the trains, and all their four clocks are synchronized using the light pulse criteria as discussed in the paper. While the trains are stationary, passengers go to sleep. While they are sleeping, one of the trains is set moving with a uniform speed. When they wake up, will the passengers in the moving train be able to find out that the train is running without looking outside? The answer is obviously no, because the principle of relativity tells us that absolute uniform motion cannot be determined. That means if the passengers in the moving train perform the light pulse test upon their clocks, which were synchronized with the stationary clocks, they must find them synchronized, because if they don't, absolute uniform motion of the train gets revealed, violating the principle of relativity. The clocks in the moving train must pass all possible synchronization tests to conceal the absolute uniform motion. Therefore, the clocks on the two ends of the moving rod in the 1905 paper must also pass the light pulse synchronization test. It shows that the two postulates of special relativity theory, the principle of relativity and the constancy of speed of light irrespective of the motion of its source, are actually irreconcilable, and simultaneity is absolute, not relative. And since this notion is the foundation of the theory, the whole theory, including the Lorentz transformation equations, length contraction, and time dilation, as formulated in this theory, stand categorically disproved. Thanks a lot for watching. Please do share your thoughts in comments. You can read my detailed paper on this subject shared on the figshare platform. It's been now improved a lot. If you read the earlier version, link is given in the description. Thank you very much.